Hi guys, it's Michelle and I have my final summary for Extending Children's Mathematics, Chapters 7 and 8. Pretty interesting chapters. Once again, talking about building on the foundations and continuing with what the children already know, with their own strategies and taking it from there. It was interesting that it said we're introducing fractions at this point as a new notation for familiar numbers. And how numbers have value based on their placement in the number. It's important to show kids that and that they need to understand that. It seems like a very simple concept, but I've been in a few classrooms where if they mess up the place value quite often, and if they don't understand the place value, they obviously don't understand the number and how to manipulate the number. And that numbers in decimal notation highlight how numbers are grouped into multiples of powers of 10, which is a very important topic in Chapter 7, saying that one of the most important goals in early base 10 instruction is for children to understand that numbers can be composed of groups of 10, and that word problems using base 10 and groups of 10 is very effective for kids to figure out. It's kind of an easy process for them, easier process with that kind of a number. It's what they'd call a friendly number. I know my math coach talks about that all the time, getting to a friendly number and working from there. The word problems with the base 10 numbers, they have a similar structure to multiple groups problems, but they have a 10 in the group instead of a fractional amount. And once again, it's talking about children have different, varied, and multiple strategies for solving these problems, and we have to let them choose and figure it out and see what works best for them. It talked about a particular teacher, Ms. Andrews, teaching decimals and how she differentiated what the kids had to do, but she didn't break them up into different groups based on what they could do or already had done. It showed how there was a variety of levels of understanding in her classroom, which we all have, and that she had to think of the students and how the students thought. There was a variety of levels of thinking in her class, and we all have this. We have our kids. Some are very good at things, some are very bad at not very bad, but they're not as good at things, and we have to think about how they think and figure out, listen, we always talk about formative assessment, walking around, seeing how they think about the math, what they think about the numbers, and what they're doing, the operations, so we can go from there and plan from there, which was very important. And once this teacher, Ms. Andrews, I thought this was good too. Once she figured out what the different solutions the kids had, then she grouped them. If they had a similar solution to solve, she put them in a group together. She worked on understanding students' prior knowledge of the base 10 and fractions to see what they could solve. And, understanding how our kids are thinking, our students are thinking, and understanding their prior knowledge is very important. You need a jumping off point, a starting point, and that's an important thing to assess, especially at the beginning of the year when we meet the kids and figure out where we're going. In this chapter, she had a couple of groups. Group A had no evidence of using the base 10 to solve. Group B, they used fractions to solve. Group C used relational thinking, using both base 10 and fractional relationships to solve these problems. And Group D used relational thinking. Ms. Andrews, she discovered that there was definitely a broad spectrum of understanding within her classroom, and once again, this is what we have to deal with. Being in math class just the other day, they're all at different levels, the kids, and different levels of understanding, different levels of picking the strategies of what they're going to do, and it's up to us to understand, as teachers, or try to understand what they're thinking, how they're thinking, why they're thinking, and we can guide them, show them, and help them. It also talked about using open number sentences as tools for developing decimals, which is interesting. So that's already the open number sentences. You're having the kids solve for unknowns or variables, which we had touched on when we did our presentation. That's a little bit of algebraic operations at this stage, trying to introduce it at a lower level to them. And when they understood what they were solving for, Ms. Andrews gave them more complex problems to see how they decomposed the numbers. Once students showed the relational understanding of the tens, the ones, the tenths, the places, and the notation of the decimals too, the teacher introduced the decimals by stating that decimals are another way to represent fractions. And even though that's true, I don't know if I ever really thought of it in those terms. So that's a very interesting thing to show the students when they start to think about it. This is the fraction, this is its coordinating, decimal. I mean, obviously we do percents and stuff, but that's probably not an easy thing for elementary students to relate to each other and get a grasp of. So that's important. And once again, it says decimal instruction, pardon me, can lead students to integrate their understanding of base 10 and fractions. When they figure out that the decimal is related to the fraction, it's a different representation of the unit, and when they can break it down using what they've already learned for base 10, they start to see the connections. And that's, I think, what we've been talking about the whole time. Chapter 8, talking about, once again, children. It's a big thing, I think. Children must build upon and extend their knowledge to now learn more difficult and powerful operations with the fractions and decimals. It's all about these layers. It's all about starting and then going up and up. You learn this, you learn that, and it kind of wraps around, and everything relates to each other. Talking about adding and subtracting the decimals, adding and subtracting to combine like units, using, once again, realistic, real-life context quantities, such as cookies or fruit that the kids will understand. Showing them grouping with the decimals. When the students solve equal share multiple groups problems, they have the opportunity to combine like fractional units. And once they understand the equivalent fractions, then we can extend it to the non-equivalent fractions. It goes on to building upon their foundations, their strategies, the concepts. Once again, still not letting them just learn the rule and throwing algorithms at them, still letting them explore. And I think that is the general theory and concept of not only the book, but all the things that I think we've talked about, that, kids have to learn these math concepts. Kids have to learn their own strategies and other math strategies and to be able to solve. They have to. But instead of just rushing through it, they have to find the way that suits them best. All our kids have different learning styles, so they'll all have different strategies, and we have to support that. We have to work from their prior knowledge. We have to help them make the connections, help guide them in the right place. And once we understand how they think about the numbers and what they think the relationship is, we can go from there. And I think that this book, Extending Children's Mathematics with Fractions and Decimals, does relate back to our Vanderwall text, all of our presentations, the articles, everything. It's kind of like one big circle of everything, that it has to be connected. You have to show this kid stuff in the context that they'll understand. You have to let them explore and find their own ways, their own strategies, and make sure that before we guide them to the next step, that they've already understood the main concept. And that's it. Thank you so much. Bye, guys.